Hey everyone, welcome back to my YouTube channel, Summarized AI. In continuation to our series, today we will explore exception handling in Python. An exception in Python occurs when your program runs into a problem it doesn't know how to handle, causing it to stop running. Think of it like you are following a recipe and suddenly it says add egg, but there are no eggs in the fridge. You can't continue, so you stop cooking. That's what happens to Python. It stops the program when something unexpected occurs. We have some common example as dividing a number by zero. For example, 10 divided by zero. When you try to divide any number by zero, Python doesn't know how to perform this operation. So it raises a specific exception as zero division error to tell you that dividing by zero is not allowed. Another example is try to open a file, but that file doesn't exist. So when you try to open a file that is not in the specified location, Python can't find it. So it raises a specific exception as file not found error to tell you the file doesn't exist. Similar to this, we have multiple exceptions to handle. All our situations cause exception to occur. If Python doesn't know how to handle the error, or that specific scenario, it stops the program abruptly, shows a message called a traceback, which tells you what went wrong and where in your code it happened. Let's go back to our Visual Studio Code and try dividing 10 by 0. So let's create a file, say practice.py, okay? And here, if you say print 10 divided by 0, okay? We did not get any error. Now, if we try to perform this operation, it gives us an error. But if you try any other number, like if you try 2, it won't give the error. It will run and give the output as 5.0. But with 0, it is throwing an exception, which is 0 division error. Here, Python first runs the code inside the try block. Okay, so we are going to talk about the try block, how we can run this particular code with the help of try block. But before that, let me tell you one more thing. For example, if we have this print and we are writing start, okay, and then after this we are writing end, execution of our code. Okay, now if I run this, let me run with a positive scenario first. We saw start 5.0 and good. Now if I run this 10 divided by 0, let's see what happens. Here, if you see, it printed start, and as soon as it thrown an error, it did not print end because the program abruptly got ended because it threw an exception. Now to handle this scenario, we can use exceptional handling with try and except to catch these problems or exceptions and keep your code running smoothly. Okay, so let's see how it works. So now, because we are getting an exception on this line, what we can do, we can write something like this, try, okay, try this particular statement or code, block of code, or if it doesn't work, catch this particular exception as zero division error. Okay. And here you can print divide by zero, not allowed. Great. Let's see the output. Now, if you see, it printed this as start and then it threw an error. Then it went into the accept. It printed this particular statement and it printed end also, which means our code ran successfully from start till end. It did not get break because of try and accept. Okay. As we know, dividing by zero is not allowed in math as well as in Python and other programming languages too, like Java and C Sharp. It doesn't allow. So Python raises zero division error. Instead of crashing the program, Python looks for an except block that can handle the type of error. It finds one that matches as zero division error, except block, and runs the code inside it. Great. Excellent. Now we have one more scenario. So we have value and we are saying value equal to input. And then we are saying enter number. Okay. And then we are printing this particular value here. Okay. Great. I have entered a number here as 4. It printed. Now if I will again execute this program and I said, Imran, I'm not entering a number, it will not give the error because we are not typecasting. Now if I go ahead and write int, where I'm typecasting the input into int. Okay, so let's try that first. So I will execute this particular code. I have given 5, it printed 5. Okay, now again, if I try to execute the same code and in place of int or number, if I give anything else, like let me give a, okay, it will throw an error, value error. It says invalid return for int with base 10, okay, which is not an int. That's what it is saying. Now to catch this particular scenario, we have one error type which says value error. Okay, so we will go here and we will say accept, and let me get this inside. Okay, now let's say accept, and we are saying value error. Okay, and it will say only numbers are allowed. Okay, it will print this particular error. Now let me go ahead and again execute this code. Now I have an enter number. I printed 45. It successfully ran. Now if I go again and say A, it did not block the code. It went into the accept because it knew it is a value error and it printed the only numbers are allowed. So here we are good. Great. Now we have one more thing. In exception handling of Python, we have one more statement, which is else, one more condition. So we have try, accept, and after try, accept, we can have one more thing as else. Okay, and here I'm printing inside else. Okay, now if I execute this particular program, I see enter number. I entered number 12. It printed this 12 and it printed inside else. Okay, now let me again execute this code, and this time I'm going to provide A. You see, it printed only enter numbers. It did not print inside else. Why? Because this else will come in picture only and only, and it will get executed if the code successfully run. If the try statement successfully run, then only else statement will get run, or else it will throw an error. Okay, cool. Now, similar to else, we have a finally block. Okay, in this finally block also, we will write one statement and say inside finally. Okay, so we have try, we accept, we have else, and then we have finally. Great. Now let me execute this code and let's give a number at 12. Okay, I gave. So it printed the number, correct? It went inside else because it was successfully running. It did not go into it accept. Then it printed inside finally. Okay, it printed inside finally. Great. Now what I'm gonna do is this time I'm gonna provide string, okay, or a character. Now you see it went inside accept. It printed this. Allow numbers are not, only numbers are allowed. And then it ignored else, and then it printed finally, which means in any of the scenario, if exception occurs or not, the finally will always be running. Okay. Now we can catch multiple exceptions also. Okay. We can catch multiple exceptions also. But before that, this finally comes into picture if we are working with files or making a connection, third party connection. So we can close those files and connections once we are done. Either it got failed or succeed, doesn't matter, but we have to close that particular file which we have opened. Okay, we will see this particular finally working in our file input output module. Okay, yep. So now if I wish to cover two different exceptions, okay, for example, value error, or I have one more error we discussed earlier, zero division error. Okay, now for example, I have this value and I'm saying value divided by, or I would say 10 divided by value. Okay, let's see how it works. Now, let me clear the screen here and I'm saying, let's execute this code. And here I say, provide the input as 5. Okay, it's successfully executed. There is no issue. Okay, now again, if I execute this code and I provide 0, then at this point of time, it will throw an exception. It will go inside the except block. Okay, because I have given 0 and divide by 0 is not allowed. Now again, if I execute this code and at this point of time, if I provide string, then again it will print the same output. But the main problem with this particular statement is where we are writing both the exception together, we will not be able to identify which exception occurred. Okay, we cannot, we will not be able to identify. So for that, what we want to do is we are going to duplicate these two lines. Okay, and here we are saying value error, and here we are saying 0 divide by 0. So we are saying here only numbers are allowed, and for divide by 0 we will say 0 is not allowed. Okay, great. Now let's go ahead and again execute our code. Okay, now at this point of time, let's provide 0. It will say 0 is not allowed. It went into this particular except, but it did not go inside. Sorry, it went into this one. It did not go inside this one as a value error. Okay, 0 is not allowed. 0 division error. Great. Now, if I again execute this code and if I give string or a character, it will say only numbers are allowed, which means we are able to catch the specific exception. Great. Now, if I want to print the error, what exact error we are getting, correct? So for that, we can create a variable of this particular exception. Okay, so I'm saying except 0 as E. Okay, and there below I can print this particular E. So now if I clean my console and after clearing the console, if I enter 0 here, okay, it says 0 is not allowed, which is this one. And E is saying division by 0 exception. It is throwing. Great. So this is how this try, accept, else, and finally works. Great. Now, normally Python raises exceptions automatically when it encounter an error, like dividing by 0 or accessing a missing key or file not exist. But sometimes you want to raise an exception manually to signal that something went wrong in your program's logic or data. For example, if our program is dealing with age and someone enters a value less than 0, it should raise a manual error or exception. Let's go back to our Visual Studio, okay, and clear this particular content, whatever we have written the code. And let's handle a scenario of age less than 0. So we are saying diff function set underscore age and take age as a parameter and say if age is less than 0, then you can say raise value error. Okay. And you can say here age cannot be negative. Okay. Age cannot be negative. Now, after that, we are printing here age said successfully. Okay. Now, let's run this program and then we will discuss. We are saying set age and provide the age as 1. And let me clear the console again. Let's execute this code. Now it is saying age set successfully. Okay. Now, what I'm going to do is I'm going to give an age negative. Now let's execute this code. Now you can see it throw an error. And the error it thrown is age cannot be negative. Okay. So we used a raise keyword to raise a exception. Okay. Great. So this was all about raising an exception, but sometimes the problem is not a Python error. It's a rule in your program that gets broken. A person's age can't be negative or a password shouldn't be empty. It should follow some specific rules like minimum length or including numbers and symbols. To handle all the scenario, we create a custom exception. So let's try to create a custom exception. So for that, I will be creating a class and saying invalid error. And here I will be passing the out of the box exception class provided by Python. And I will be giving 3 double quotes and say raised when age is negative. Now we are going to throw the custom exception. Okay. Now let me control that the code. Okay. And I got this here. Now what I'm going to do is I'm going to replace with this one. Okay. Now you see here, I got the value error here. Age cannot be negative. Now let's see the output with custom exception invalid error. As soon as I executed this code, it thrown a custom exception as invalid error and age cannot be negative. So the line creates a new exception type called invalid age error. Parenthesis having the exception means the class inherits from Python built-in or out-of-the-box exception class. Now we have checked how we can consume the custom exception. Okay. Now you can also create a silent exception block using pass keyword. Silent exception block means the exception got occurred and nothing got broke. Okay, so let's control that our code and I wish to go to the earlier code for that. We just have to make one word change and it will work. Okay, so for example, I have this. Okay, now what I'm saying is except and here I will say pass. Okay, now let's see what happens. And here I'm saying print and okay. Now let's execute this code. And before executing, let's clear the console and execute. Enter number. I'm entering string. It says and. So program did not got broke and it ran successfully. It printed and. Great. Now let's talk about one of the fun fact we have in Python as EAFP. In Python, programmer often follow the EAFP principle, which is nothing but easier to ask forgiveness than permission. This means developer or programmer typically attempt an action and handle resulting error rather than checking conditions in advance. Here, let's try that. Let's write code following EAF approach. So try, then say value equal to my underscore dictionary. Okay. And here I'm saying key. Okay. Now we can say accept key error. Okay. And then value equal to default. The double quote. Sorry, this should be colon. Okay. Now I have a dictionary. Okay. In that dictionary, I have a key. So let me go ahead and define the dictionary or else it will give an error. So I have defined the dictionary, empty dictionary. Okay. Now, if I go ahead and run this code, I won't be getting an error. I'm not getting any error because we got the error on this line. Okay. And let me show it to you once. Remove this particular code, write it here, try, see. It is saying key error. This particular key is not available. What we are trying to access inside my dictionary. And the same exception got handled using key error. Okay. See, no error. Okay. Instead of check whether key exists in the dictionary, the code just try to access it. If it fails, it catches the key error and handles it gracefully. And same thing can be done by below LBYL approach. Here, LBYL stands for look before you leap, which is another programming style. And it's essential the opposite of EAFP. So let's see if I wish to handle this particular scenario with LBYL. So what I'm gonna do is I'm gonna write here key in. Okay, I'm saying if key in my underscore dict value equal to my dictionary and then key, else else it will be a value as default. Okay, and let me try to print the value. Okay, so let's see what it prints. It printed default because this particular key doesn't exist in my dictionary, and it will not go inside this particular condition. It will not execute this particular code. It will go inside else and it will assign the default as a value. Okay, so this is the LBYL approach. So the question here is why Python prefers EAFP? Because it is cleaner and more readable code and fewer conditions checked required. Also faster in many cases. Avoid redundant pre-checks where it is not required to do not check. It will check at the time of failure and the failure is rare. There we are going to use. Now Python's philosophy, very important philosophy. It's better to ask forgiveness than permission. Align with Python's dynamic exception friendly nature. Yep. Now let's proceed further. In Python, we can suppress exception temporarily. And for that, we can use suppress from context list module. Let's see how this suppress works from context lib module. From context lib, import suppress with suppress file not found error. Let's try to open a file test.txt. Okay, let's try this. See, if I try to open this file, it is not there. Okay, it is not giving the error. It's suppressed. Now, if I will to prime something here, let's print inside suppress. Okay, inside suppress. Let's see what happens. And I'm going to, okay, great. Now you see it went inside suppress, but we know this particular file doesn't exist. So it did not raise an exception. It just suppressed this particular exception. And if I go further and if I print something here, you will see the code got code got successfully executed. There was no error. See, inside suppress and then end. Cool. It suppresses the error. Great. Now in the exception, we have exception family tree. Exception family tree is nothing but it talks about the complete exception, which is nothing but the base class and the derived class inside the base exception. So base exception is the root of Python's exception hierarchy. All built-in exceptions inherit from it. It represents system level events like system exit, keyboard interrupt, generator exit, or exception, and not just regular runtime errors. System exit is an exception that is raised when the Python interpreter is told to exit, typically by the built-in sys.exit function. In other words, when you call sys.exit, Python doesn't immediately kill the program. It raises a system exit exception internally, then it gets terminated. This allows us to handle all our cleanup tasks or high-level exception handlers to catch it, if necessary, before the interpreter actually gets stopped. Most runtime errors or exception inherently from exception like value error, zero division error, etc. Great. So this is all we had today for exception handling in Python. And I'm thankful of you for watching this particular video. If you found this video helpful, please don't forget to like this video and subscribe to the channel. I will be coming up with more videos on Python, AI, and programming tips. So make sure to hit the notification bell to stay updated. See you in the next video. Thank you.